In programming, a library is a collection of related pre-written code. Libraries are how we, as programmers, share common and helpful code with each other, with the different programs we write, and even with the different processes running at the same time on our computers. Let's explore a bit. One of the more common functions that you've probably been using is the printf function. Now, printf isn't some magic function that's been hard-coded into the computer. Rather, it's part of the C standard libraries, which are a collection of functions that comes with the C programming language. Since printf isn't built into the computer, that means that there was some programmer who actually went in and wrote the printf function and bundled it with the rest of the standard libraries so that future programmers wouldn't have to duplicate the effort. And we're sure thankful that that's the case, because check out how much code it actually takes to implement printf. The C standard libraries, of which printf is a part, are one of the most important tools you have in tackling CS50. In addition to the input-output library, where printf lives, there are a bunch of other libraries that you'll probably use over the course of CS50. For example, the string library has functions to compare C strings, get their length, and concatenate them. And the math library gives you helpful constants like pi and e. Now, compared to the standard libraries of other programming languages, the C standard libraries are really small, but they still have a significant amount of stuff. And that's not to say that the standard libraries are the only C libraries. There are many more out there in the world for you to use, including the CS50 library, cryptography libraries with encryption and decryption functions, libraries with functions to encode and play back video, and so on. This brings us to an important aside. One of the essential skills of engineering is knowing the tools available in your toolbox so that you can use them and avoid reinventing the wheel unless you have to do so. As programmers, libraries are one of the most important tools we have. When you find yourself facing a task that seems tedious or commonplace, like finding the length of a C string, you should ask yourself if it might be the case that someone's already done the same thing before. Chances are that you could find some help within a library. So in technical terms, a library is a binary file that has been produced by linking together a collection of object files using a tool called, well, you guessed it, the linker. Object files are those .o files that you get when you compile C source code. When programmers write libraries, they typically separate their C code into two types of files, header files and implementation files. A header file, by convention, is given the .h file extension, and it contains code that declares the library's resources that are available for you to use. These resources include functions, variables, structs, type definitions, and so on, and together they are commonly referred to as the interface. In fact, if you're ever wondering what's in a library, the header files are the place to look. For example, you can pull up user include standard.io.h and check out everything you ever wanted to know about the standard.io library. There's a lot of stuff in here, and it can take a bit of time to wade through. However, along with Google and the man pages, this is the place to go if you're wondering how the standard.io library functions work. So one key thing to note here, though, is that header files typically do not include function definitions, that is, the actual function implementations. This is an illustration of an important computer science principle called information hiding, also referred to at times as encapsulation. As the user or the client of a library, you don't need to know about the internals of the library in order to use it. Remember seeing printf just a bit ago? Have you ever seen the actual code before? Well, I assume that you haven't, even though you might have used printf tons of times. All you had to know was the function declaration, present in the standard.io.h header file. Anyway, the benefit of good information hiding is that you and the programs you write are insulated from any changes in the code of the implementation of library functions. If the implementation of printf changes, you don't have to go and change all of your programs that use printf. So where does the implementation go? Well, again, by convention, the implementation goes in a file with the .c file extension. Usually header files and implementation files go hand in hand, so if you've declared a bunch of new string functions in mystring.h, then you'll define all of those functions in mystring.c. So then the header and implementation files are then compiled, creating object files that are then linked together to produce the binary library file. The library writer will then ship the binary file, along with the header files, to programmers who want to use the library. At this point, the .c implementation files aren't needed, except to recompile the library from scratch, so they're often left out. To use a C library, you have to do two things. First, you must pound include the library's header files in the source code file where you wish to use the library's code. This informs the compiler of all of the declarations of functions, variables, structs, etc. present in the header files so that the compiler can, 1, ensure that you're using the library's resources in the proper way, and 2, generate the appropriate assembly code. Depending on where the library's header files are located, the pound include syntax varies. If the header files are located in the system's default include directory, typically user include, then the angle bracket syntax is used, as in pound include left angle bracket standardlib.h right angle bracket. However, if the header files are located in the same directory as your own code, the double quote syntax is used, as in pound include quote mylibrary.h unquote. The second thing you have to do is to link in the binary library file when you compile your code. This is a super important step. Remember our earlier discussion about how header files don't contain implementation code? If you forget this step, you'll get errors about undefined symbols referenced in your code. To solve this, use the -l flag, followed immediately, without a space, by the name of the library. On many systems, including the appliance, the C standard libraries are automatically linked for you. However, the math library is sometimes bundled separately and might need to be linked with -lm. On the appliance, we take care of this for you, and we also link the CS50 library with -lcs50. You can see all of this on the appliance when you run make. Now you should have the knowledge you need to use libraries in C. Have fun exploring. My name is Nate Hardison, and this is CS50.